0.8 plus 0.04, so 0.84. So there we go. So again, these add up to 1 also. So it looks like we're good. Here's our square of P, this matrix here. Now that I know that, I can find the third power a little more easily, because P to the third power is the same thing as P times P squared. Yeah, P times P squared. So I just have to take this matrix times this matrix and see what I get. All right, so that's 0 plus 0.16. That's 0 plus 0.84. That's 0.64 plus 0.032. And so I think we get 0.672. So I will admit, I calculated these out beforehand. So I know my numbers are right this time. So you guys might check them yourselves as we go. And then 0.8 times 0.2 plus 0.2 times 0.84 actually is 0.328. And you can check, that's a really bad 6. These add up to 1 as well. Okay, so this is my third power. And so now I'm asking for which one represents transitioning from B to A. Well, I'm being consistent with my labels, and so the first row is A, second row is B, first column is A, second column is B. Since I've been consistent, B to A is B to A. So it's 0.672. That is my answer. So the probability of going from B to A after 3 steps is 0.672. Okay. So this is a perfectly fine way to solve a problem like this. Yeah? Just find the whole matrix and then point to the number that you need. But you might, if you like to cut, save time and be lazy, which I do, you actually don't have to compute this entire matrix at any point. You know that you need this number in this spot. And so you might notice that maybe I can get away with only finding certain entries of the matrix. For example, what do I need to know to find this number? Well, I know that I'm multiplying these two matrices. To get this number, this is the second row, first column, yeah? So that means that I need to know the second row of P and the first column of P squared. So really, it's enough for me to know this, which I already know, and it's enough for me to know this, which I'll have to work a little bit to find out. But I don't actually need all these other numbers. I just need this row and this column, and then I could just multiply them together and get this and be done. So if you want, you could sort of skip some steps and not multiply out the whole matrix. You could just multiply the rows and columns that you need if you know what they are. So I invite you to practice that if you want. If that makes you nervous and you don't want to skip any steps and you want to just do everything very carefully, go ahead and just multiply out the whole matrix. That's fine too. Do whatever you want to do. But I want to point out that that is something you can do to save a little time if you want. And maybe I'll point that out again on the next couple examples. So, okay, so I'm going to pause here for a second and ask, are there any questions? Okay, doesn't sound like it. So I'm going to do another example here. Something a little more complicated, at least in the sense that instead of a 2x2, let's look at a 3x3 situation. So here's another example. Again, I'm just going to draw a transition diagram, and from there we will find the matrix and the appropriate power to solve the problem. So here's our transition diagram this time. There are 3 states, A, B, and C. We have an arrow to A, like this, 0.9. This is 0.1. This is 0.9, and this is 0.1. Okay. So here's my transition diagram. I'm missing some arrows. So like I don't have an arrow from B to C or from C to A, for example, but that's okay. One thing that's good to do sometimes is to think about what you think certain answers should be, or what they should be like. So here's our question, and then I'll show you what I mean. Here's what we're going to ask. We're going to ask, what is the probability of going from C to A after just, let's just do 2 steps here. After just 2 steps. All right, so C is down here, A is up here. I have these two, I could get to A by going B and then to A. And those have big probabilities on them, that's 90%. So we should sort of expect that the probability will be high because the arrows that get from C to A are heavily weighted. They have nice big probabilities of like 90% each. So you might ask sort of qualitatively like, oh, it seems like it should be pretty likely. I bet the probability is pretty high. The odds of getting sort of stuck at B and going back around are low because this is only labeled 0.1. So we should expect some big number here, probability-wise, some big probability. Anyway, it's good to think about sort of qualitatively what might happen in your system before you start computing. It's another way to sort of check your work, if it meets your expectations or not. I expect a big probability. If I get something really small, I probably did something wrong. So let's see what happens. So the first thing, as always, is let's find the transition matrix. So again, my rows are going to be labeled A, B, C, and my columns will also be A, B, C. So I'm looking for probabilities of going from these to these. So what's the probability of going from A to A? It's 1. And then there are no arrows from A to B, and there are no arrows from A to C. So it's 1, 0, 0 is the first row. So you might notice if you ever have a 1 in a row, everything else in that row has to be 0 because the row has to add up to 0, adds up to 1. And we're not allowing any negative numbers because that doesn't make any sense for probability. So if there's a 1 in the row, everything else is 0. So I get 1, 0, 0. Next, what's the probability of going B to A? 0.9. And the probability of going B to B is 0.1. And then 0 is the probability of going B to C. And then the probability of going from C to A is 0. Probability of going from C to B is 0.9. And the probability of going from C to itself is 0.1. Okay. Maybe it's worth pointing out, there's no way, this probability of C to A is 0 because there's no arrow from C to A. So it's impossible to get from C to A in 1 step, but we're asking about getting there in 2 steps. And as we'll see, that is possible because, again, I can't go this way. So I'll get something that's not 0. Anyway, I want to find it in 2 steps. So what would I do? I would look for P squared. Take the square of that matrix. So that's some other matrix. A, B, C, A, B, C. And so I could go and compute this entire matrix and then just point to the number I need. But maybe, again, I'll just kind of notice, what do I need to solve this question, to solve this problem? I'm looking for a probability of going from C to A. So I might look at my matrix for the corresponding entry, C to A. So that's right here. So I need whatever this number is going to be. This is in the 3rd row and 1st column. So if I really want to just find that one number, all I need to do, instead of multiplying out the entire matrix, maybe instead what I would do is just take the 3rd row and the 1st column of C and multiply them together, because that's what will give me this entry. And I actually don't care about the other entries if I'm just answering this question here. So what do I need? I need to multiply this row by this column. And that will tell me what this entry is here. So we can do that. So I'm going to take 0 times 1 plus 0.9 times 0.9. That's 0.81. Plus 0. Sorry, something's wrong. No, nothing's wrong. OK. I just changed the number from my notes. That's fine. So 0.81, it looks like, is our answer here. 0.81. because I get this 0.9 times 0.9, and then the other things are 0. So 0.81 is our answer. So in some sense, I'm done. Yeah, I've answered the question. Instead of multiplying out this entire matrix, I save myself some work by just multiplying the row and the column that I need to get this number here. Okay. Just in case you want to see it, I will go ahead and write in the rest of the matrix, though, because I have it. I can quickly compute that here for you. And we should get 1, 0, 0, and then 0.9, 0.09, so 0.99. And then, yeah, 0.01. And then 0.09, this is 0.18, and then 0.01. So this should be the rest of the matrix, just in case you want to see that, for completion's sake. If I were to multiply this out, the square of this, I should get this whole thing. But again, to answer this question, I'm only really interested in this number right here. Okay. Cool, so we've answered the question. Yeah, there's a probability of 0.81. That's pretty good. Again, that's pretty big probability. So that sort of agrees with my intuition from the first point at the start of the problem. So I would conclude that we're probably okay. Okay. So are there any questions after this example? Okay. So yeah, basically everything boils down to taking a power of a matrix. I could ask about this for any number of steps. If it was 4 steps, I would take this to the 4th power. It becomes a little less clear how to take shortcuts once the powers get big, in which case maybe you just multiply out the matrix. I don't know. But anyway, so do practice doing these by hand, but also you can check your work with a calculator. Again, on an exam, I might want to see a couple of these written out by hand just to see that you know how to do it. So do be prepared for that. But again, check your work with a calculator if you wish. How are we on time right now? We are very good on time. So I think the last thing I want to just mention is just a fact that I've already pointed out, but I just want to solidify it with one little bit of vocabulary. So I'm just going to make a definition here. We're not really going to do anything with this definition.